In this video, I'm going to give a quick introduction on how to get jEPlus+EA 2.1 and run the included example project. You can find the information of jEPlus+EA at jEPlus.org. Please note that large part of the user's menu are still under construction at the time when this video was recorded. jEPlus+EA is an extension to jEPlus. It adds the capability of performing Monte Carlo simulation, global sensitivity analysis, constrained single or multi-objective optimization, and visual data analytics on top of the parametric models defined in jEPlus projects. We will, of course, go through these methods one by one in our future videos. If you have used the previous versions of jEPlus+EA, the biggest difference you may notice is that the version 2 does not work without a live internet connection. The reason is that the new jEPlus+EA relies on the JA Online platform for its algorithmic functions. The benefits, on the other hand, are more interactive data visualization tools and easier data sharing and collaboration. We will introduce the concept of the JA platform in a separate video. Today, however, let's just see how jEPlus+EA works. Before we downloading the program, though, please make sure that you have Java installed on your computer. jEPlus+EA requires Java version 8. Newer versions of Java will cause problems. You can download the Java runtime environment here. To check if you already have Java or its version, you can open a terminal or a Windows command prompt window and type java -version. You will see the version details here. You will also need EnergyPlus or Transys required by your project. For the example project, you need EnergyPlus version 8.9. You can find the current and the previous EnergyPlus versions here. Now let's download jEPlus+EA. You will need to agree to the license terms before getting to the download link. Once it's downloaded, make sure you open the zip archive and extract its contents to a folder. Go into the folder. You will see the main program's jar file and the two Windows batch files, one for starting in jEPlus mode and the other for starting the jEPlus+EA GUI. Unlike jEPlus, it is not recommended to start jEPlus+EA using the jar file directly. You should use the batch files instead, as they contain additional settings for the program. On Windows, you can double-click on the batch file to start the program. On Linux, you may make the batch file executable or issue the command it contains in a terminal window. Running the program in this way, you can see the command prompt window in the background, which may show you additional error messages if something goes wrong. The error message now are fine. It is the first time we run this program, hence the splash screen. Now, this is the main window. The first thing you ought to do is to get a jaweb account if you haven't got one already. Use the link here to go to the website. This is the login dialog, and you can find create account link here. And once you click it, you need to give your name and the email address you want to use. And of course, you should check our service terms and the other legal documents. By ticking this checkbox, you can submit your request. After which, an email message with the verification instructions will be sent to your email account. There we go. If you didn't receive this verification email, check your spam folder, see if it is there. And here you'll find a link. And by clicking on it, it should bring you to a screen to set new password. Submit. And now I should be able to log on with the new password. There we go. And the first time you log on, your project will show an example project that has been put there. This is not particularly relevant at the moment. Now let's go back to jEPlus+EA. You need to sign in here as well, using your email address. And your password. Check the box to state that you have accepted JEA service terms. And once you log on, you see the same example project. But if you check just show my own project, it should disappear. Now before we start running our example project, you need to set up the simulation programs. For Energy Plus, we want to use version 8.9. So I'm going to browse to the folder where Energy Plus is installed. It's this one. And if you have Transys, you can select your Transys directory as well and set up scripts, etc. But we can do that later. Now I'll save the configuration, so this will be enough for now. Now we can load our example project. If you go to File and open jEPlus project, I'll show you where the example project is. And let's go into the folder. There's only one project file in there, and I click Open. Now if you look at the center part of the screen, let me maximize it. The project has been loaded, and the information contained in the jEPlus project is represented here. Now if you want to see what's in the jEPlus project, you can actually use this button to open it. And you can see in the jEPlus project there are 12 parameters defined. And if you go back to jEPlus+EA, you can see the list of variables, which contains 14 instead of 12 parameters, because the weather file and the models are considered as parameters as well in jEPlus+EA. In the jEPlus project, we actually have 4 different weather files loaded. If you go back here, and you see that there are 4 different weather files. They are the current Heathrow weather file and 3 with future projections. Okay. Now the next section in jEPlus+EA says simulation outputs, and also there are constraints and objectives. Those are also defined already in jEPlus. If you go to the result collection tab, apart from our usual result collection methods, there are 3 additional categories. The first one is report vars, which include definition for, say, identify the heating consumption as V1 and cooling consumption as V2, etc. And this will be imported here as V1 and V2. But in jEPlus+EA, you see there's no information about how V1 and V2 is calculated. There's a reason for that, which I'll explain in the next video when we talk about how jEPlus+EA works with the JEA platform. The constraints are also imported from jEPlus. If you go to the constraints section, and the input are fairly similar. In fact, you can define all of this in jEPlus+EA, but it's recommended to do this in jEPlus because this is normally where you load the project from. And if you don't define it here, every time you load the project, you have to manually put in these details, which is a little tedious. Now, If you go to the next tab, which is called Algorithm Settings, by default, jEPlus+EA will run a optimization process using the NSGA2 algorithm. In this example, we shall try sensitivity analysis using the Morris method, and we change the sample size to 20. For Morris method, the actual sample size is sample size for the initial points, that is 20, times the dimension plus 1. So if you look at the optimization problem tab, there are 14 variables. Hence, the actual sample size is 20 times 14 plus 1, that is 300 cases in total. This computer can run 16 parallel simulations, so I'll change it to 15 probably in both these two fields, which means each time it will run 15 jobs. When the results back, we'll see points appearing in the scatter plot. At the moment, there's nothing, obviously. Now let's go to the top. There are some fields for you to input information about the project you're going to run. The only important field is the ID, which must be unique amongst all your projects you run. So I'll call this one example 1 as the ID, and this is the example project. First run. And the first run, we can say this is a Morris method, Morris SA, and run node something. Sample size 20. It's just some nodes. And now we have all the information needed to set up new run. So I'll click on the create button here. What jEPlus then does is to upload all the jEPlus project files and all the project settings to the server. And once you finish it, you can see the status of the project has changed to online. And you see the start button here. So on the left side of this tab are the controls and the status of the jEPlus+EA project, and also the controls for running simulations. Okay, before I start running the project, we can go to the website and see if there's anything new. Let me update this page, and yes, indeed, you can see your example project is appearing here now. And if you click on that, you can actually open the project file and see all the details of the project you have created. We're not going to do this at the moment. Let's go back to jEPlus+EA and start the project. Okay. Now the status of the project has changed to initializing, but I don't think my computer is actually doing anything at the moment. This is because we need to tell jEPlus+EA how we want to run the simulations first. There are two options included if you are running a EnergyPlus project. You can use your local computer to run the simulations, or use the JS client to run simulations online using Ansim's JS service. We'll use local simulation this time. And if you remember, we have set up the local simulation engine as the EnergyPlus version 8.9. So this should work. But we need to tell jEPlus+EA that we are ready to run simulations by checking this box. Okay. Now, as soon as this one is checked, you can see jEPlus+EA has started running some simulations, and the first iteration has finished. And now it's running the second iteration. Right. The reason that there need to be a checkbox to enable a run. I'll keep it for now, and we'll review that in the next video as well. Now if you go to the scatter plot, you'll see some data coming back already. Right, so each point is one simulation case. If you hover your mouse pointer on a point, you should see the details of that of this case, including the input parameters and your output metrics, such as objectives and constraint values. Okay, and the circles with gray edges are Infeasible solutions, because this example have two constraints on lighting and thermal comfort, and if the solutions are not feasible, it'll have the point will be smaller and with a gray circle around it. If it is feasible, i.e. the lighting consumption and the discomfort hours meeting our requirement, then you get white edges. At the moment, there are only very few feasible solutions. The new results are still coming. The blue dots here are the latest cases being simulated. You can see in each iteration there will be new blue points appearing. That's another set. All the simulation cases have already completed actually. And you can see the status of the project has changed to terminated. And here it shows the number of iterations and how many cases in total have been evaluated. Now this is 220 instead of 300 as I originally thought. The reason for that is in this run, all the parameters that has only one possible values, like those, are excluded. So in fact, there are only 10 parameters, hence the total number of cases are 220. Let's set up a optimization run and see if we can get a few more feasible solutions. To do that, we go back to Edit Project, and now we go to Algorithm Settings and change it to NSGA2. And we shall change the sample size to 10. There's no particular reason for this, but I like number 10, and it tends to work in most cases. And we set the maximum generations to 80 probably, instead of letting it running for too long. So it will run 80 generations of 10 each in this case. So I would need to change some nodes as well. So this one is optimization, and I get population size 10, and then I'll update the configuration, and it says it'll ask me to apply changes. I'll apply it, and it says the update has been submitted. Now if I start the process again, it will continue with the existing results, but start a new optimization run. Okay, so if I continue, now again I need to check this run option if it is unchecked, otherwise it won't run simulations. Now I check it, and it started running simulations again. We shall see new results coming up fairly quickly. Okay, in the meantime, I can show you a few more new features in this version of jEPlus+EA. One new feature introduced in this version is the highlighter and the select option. So, see, by default, jEPlus+EA highlights the optimal solutions, which are red, and the recent simulations, which are blue. But if I enable this option, I will highlight the cases based on the criteria you have chosen in here. For example, if I just want to show the cases with a particular weather file, see this one, that's the current London Heathrow weather file, and I don't want to limit it to feasible solutions, or rank 1 means the optimal solutions. So I just remove all that, and this will show you all the cases with data using the current London Heathrow weather file. And we can add another one. I changed the name to current. Okay, and then I add another one, call it 2080, and set the weather file to the 2080 one, and change the color of it to something a bit warmer. Then you see the two sets of points in our current collection quite distinctly. And if I enable the feasible ones as well, you can see there's absolutely none for 2080. But if you go back to current, this is our current best solutions, and they're all feasible. If you remember, there were only 2 in our random sample, but now after simulating for another about 200, less than 200 cases, you see a lot more feasible solutions, and the metrics have improved quite a lot as well. Right? You do see a case up there, okay, showing that this is actually 2080 weather file, and T1 is the heating consumption, T2 is the cooling consumption. You can see if you're using 2080 weather file, the heating consumption will be much lower than the current weather file, but the cooling consumption is much higher. So this is consistent to what our expectations are. Okay, if you go back to the website, and let's do an update. If you remember, our first run was a sensitivity analysis using Morris method. The results you can actually see on the sensitivity tab here. So if you go there, the first section is scatter matrix, where you can see how the solutions distributed if you plot the matrix against the parameters. And those fields are interactive. You can actually move this around, see how the selection are mapped on other charts. There are probably too many of them, but from such scatter plot you can already see some correlations between the input parameters and output metrics fairly clearly. But what we wanted is the formal sensitivity analysis results, which you'll find towards the bottom. Say the first one. Okay, so here's the sensitivity analysis results for total heating. That's the first objective function we have defined in the project. And it says it's using the Morris method, and the sample size was 20. And you get the Morris method diagram here, and also the data table beneath it. You can have a look at other sensitivity results, for example for cooling or for discomfort. If you look at lighting, I guess you can imagine the most important parameters are number 1 orientation, and number 2 is the window size. If you look at discomfort, it will be different. So the heating set point and the cooling set points are the dominating parameters, whereas insulation is also quite important, but it seems it's more dependent than other parameters than the set points. Okay, and You also get a linear regression model from your sample. This is actually the model you can copy and paste into another program to use it as a fitted linear model based on your. To the right, you see a plot of standardized coefficients of the fitted regression model. And sometimes this can be used as a measure of sensitivity as well. We shall have another video to discuss sensitivity analysis specifically. There are other tools you can use to analyze your data. The parallel coordinates chart, and you can make it a little simpler by doing that, and you can highlight the cases like that, and you can select ranges to filter out the results. The Dimensions tab is a tool called Cross Filter. This allows you to cross-selecting solutions based on their input parameters or the output metrics. For example, if you only want to see the cases with lower heating demand, and by selecting the lower range, you can see the input parameter value distribution will change, and this will give you an indicator how input are correlated with output as well. See, and all the output charts are changing with it as well. There are other charts like a box plot. This will show how the weather data affecting T1 is the heating consumption and T2 is the cooling consumption. And let's have a look at the status of our project. Now it has actually finished after 80 further generations. So the optimization process has finished. And let's go back to our jEPlus+EA and see what the result looks like. Okay, so these are the final set of solutions. The so-called optimal solutions jEPlus+EA have identified for you, and this shows the trade-off between the heating consumption and the cooling consumption. You can see quite a wide range of cases are covered, and our original two cases are somewhere there, I believe. We can actually find it by adding another one, adding another filter. Let's call it random, and change the color to yellow. Okay, and for that I want to select the first run and only the only the two feasible solutions there, and probably not limiting it to the current weather file. So as you can see, these were the original two feasible cases in the 200 random sample originally, but after optimization, we ran 670 cases, and you can see how much improvement is achieved, and all these white circles are feasible solutions. So a lot more and a lot better as well. So this shows the efficacy of the optimization process. Okay, I hope this video is enough to get you started, or at least give you a reason to start trying jEPlus+EA. Like I said, I'll produce more videos in the future to show different features in detail of this tool. Thank you.